constructive message. I haven't told you yet how to upload the homeworks. I'll do it. Today. So I'll add it when I go back from this class. I added information of where to do the upload. We are doing this with a crowd grader, and so you upload your submission. You will upload the W2P file that you can obtain from Web2Py. And then I will give you 4 or 5 days to grade 4 submissions by other people, okay? So you have to essentially download, you will be assigned, you will click a button that says, give me an extra submission to review. You will download it and you will review it. It should be quite easy. I will give you criteria for reviewing it. And the advantage is that if you cannot get something to work with your work, you are welcome to look at how other people did it. So essentially you have a variety of solutions. This is good even if you can get it to work actually, because there are many ways of doing the same thing. And you may have found a solution, but others may have found another that is also interesting. So you always gain by reading other people's code, okay? So I actually really recommend that you pay attention to it and do it well. I think, frankly, it's one of the main advantages. To be completely frank, you know, the grade of this class is done of 2 parts, you know, the homework and the project. The project is where you can really shine, and the homework is there so you can learn. And so the more you can, you know, look at how other people do it and compare notes and learn from examples by others, the better off you are actually, okay? So this is one of the things I wanted to say. The other thing is this, I will begin today or tomorrow to look at the project proposals that have already been posted. Some people ask me, what's the deadline? Well, I don't want to give you a hard deadline for the project proposal because some projects may take a little bit more to be finalized, but I would be happy if you uploaded it by Saturday, say, or Monday. The longer you wait, the less feedback I'm able to give you. And so, you know, if you upload it at the end of the next week, basically I give you very little feedback on the project, and you will complain that, you know, we didn't follow your project. So it's in part, you know, it's in part up to you to do things early and get the feedback. You don't need to think that this project proposal is a very elaborate document, right? You can write 1 paragraph on what you want to do initially if you don't want to expand on it. And then, you know, I go there and I will comment on it, and maybe I ask you to expand on some sections. And it's a working document, so we will be able to work on it later as well. But give me some idea of what you want to work on. Also, I will post a sign-up sheet so that people who wish next Tuesday can talk about their project. They can, you know, use a couple of minutes in which they can say, hey, I want to do this. If other people are interested, you know, I'm looking for 1 or 2 people for my team, for example, and I can do this, and I'm looking especially for people that can do that and that. So you have an occasion to present your project so that, you know, at the end of the class, hopefully other people I will finish maybe 5 minutes early or 10 minutes early, so that other people can come to you and you can mingle with them, you see who they are, you know, chat with them, start to exchange emails so that you can hopefully find project members if you like to have more members, okay? So that's another thing I'm about to do. Homework 2 is not yet finalized, but I will finalize it today and assign it, okay? I want to add a small piece to it. Okay, that's it. Okay. So this said, I want to talk a little bit more about databases very briefly, and then I need to talk about HTML elements. Okay, so these are the 2 things I want to do now. And if you have questions, I can also take any question, I guess. Okay, database primer. So I'll try to make it more entertaining. I didn't notice last time that I had the 2 versions of the primer. One with too many words and the other one that is more visual. So I told you how to encode a many-to-many relation in the database via an intermediate table. Okay, so essentially, databases have built in this concept of foreign key. It's essentially in a row you put the ID of another row. Okay, that's called a foreign key. Because a key in a database is an element that enables you to identify a row. And in Web2Py, and very often, there will always be a column called ID that forms the key to these table students. Okay, this ID is incremented automatically. This ID, by the way, some people were asking, is present even if you don't declare it in Web2Py. So Web2Py automatically adds an ID field to every one of your rows. Okay. And this ID field is auto-increment, is an integer in auto-increment mode. So every time you add a new row, you will get, the successive number, okay? And this ID uniquely identifies the row. So if you want to, tell the database, do something on this row, or for example, if you want to pass, suppose that you have a function and you want to edit the data for the student John, the first one there, okay? How would you design your controller so that it knows to edit the data for John and not for Helen? You would build a URL that contains the ID of the row. That is what we were doing in the example that I did in the second week of class, right? When I told you, when I built with you this example on how to edit or delete rows, I was including in the URL the ID of the row itself. Do you remember this? If you don't, I can show you as well. But I think, view a post. I was saying P is equal to db bboard request.args of 0. So request of args.0 is the first argument. Okay, so the URL will have the form default/view/ and what comes after that slash is the first argument until the next slash, right? So I'm getting the first argument and I'm using it to index the bboard. Okay, and when I generated the link to view, where is it? I forgot, but it must be in index or index 2. I think it's in index. Where is index? Here. Oh yeah, sorry, I generated in the view, I guess. No, when I give the links to read, you see I build the default view. And the arguments I say p.id, so this is post.id, okay? So I'm using these IDs. This is you will do it throughout Web2Py, and it's a very common thing to do. You use these raw IDs in order to identify, the data on which you want to operate. Okay. So if you need to say that a student has a certain major and you have a table for majors, you simply include in the student row a major ID, okay? And I showed you in code how to do that, okay? So you have two ways of saying, you can look in the references, but you can, where is my tables here? This became too wide, okay? Okay, so for example, this friends is a relation and it contains a 2 pointer to DB student, which is this table here, okay? This is one of the syntax for saying, for referring to another table, or you also can say reference DB post. Actually, I think it's a reference post. Well, I don't know, okay? I would need to look at the manual. Okay, so this is how you build one-to-many relations, and this is how you build many-to-many relations, okay? And I want to do some exercises on building some relations, some database schemas for various things we may want to do, okay, with you. Navigating many-to-many relations, you can do it in SQL, but I want to try to do it in Web2Py directly so that you know how they work. Now, I have some slides. I mean, going a little bit out of order because I have in my mind what I want to tell you, and it doesn't always match. So, when you read from the database, you're basically fine most of the time, okay? But the problem what happens when you actually want to modify the data inside the database. So, for example, you may want to do a method in which you say the user wants to buy seats 2, 3, 4, 5, as we were saying last time, okay? Or maybe you see simply a single seat. This is an example, buy seat, okay? So you build a method that is called buy seat that will want to check that first the seat is not bought by anybody else, and if it is not bought, it will give it to you, okay? And then maybe it will bill you for the money or something like that, okay? So the problem is this: your code will contain something like read seat state, write seat state, okay? And if there are two people who want to buy the same seat, if you just don't do anything extra, what can very well happen is this. I read the state of seat 1, you read the state of seat 1, we both see it's free, I write that I bought it, you write that you bought it, your right is going to overwrite mine. But I'm not told that, okay? So I'm told, congratulations, Luca, you bought seat 1, here is your ticket, no? And you are told the same, and so we both print the same ticket. So essentially, how to ensure consistency in the face of parallel concurrent access. How many of you have taken operating systems, just to know? Very few. Okay, so this is one of the basic problems of operating systems, okay? How to ensure the sanity of concurrent data, because your computer's OS needs to do this all the time. You know, you have multiple applications running. And this is actually one of the difficult things to do. There are incredibly many ways to get it wrong. And so it's essentially a great fortune that databases take care of it for us if we want. But there are various, so if you want it to be taken care of, you do this. If you have a conceptual unit of stuff that should be all done or all not done, you know, think at it as a unit of execution of database activity. Now, this either it all goes through or, you know, it better all fail. You need to put this between a start transaction and a commit. Okay? Don't look at the first line. I will come back to this slide and tell you later what it means. Okay? In Web2Py and in very many web frameworks, whenever you do an access, the access is enclosed in a transaction. So Web2Py essentially adds for you a start transaction at the beginning, and it adds for you a commit at the end. When your controller produces the results and is done with the code, Web2Py will execute a commit on the database. Okay? So if you don't say anything special, Web2Py does kind of the right thing. Okay? It gives you a transaction so that your request, either it all succeeds or it all fails, but you are not left hanging in a sort of semi-state. Let me do a simple example. Suppose there is a rule, or you know, let me draw some examples from CodeGrader. In CodeGrader, I implement access control for you to homework in the following way. I don't do a many-to-many. There is a many-to-many relation between students and assignments, right? But I don't represent it as a many-to-many relation. And I want to talk later about why I do this kind of things. Essentially, what I do is this. With each student, I list the homeworks or the assignments that the student can submit to. And with each assignment, I have the whole list of students that can submit to it. This is crazy, you know. A database purist would tell you, this is horrible. No, the many-to-many relation, and you should represent it as such. But the point is that efficiency is a fundamental design goal when you write web services. Okay, so time and again you give up, the official beauty of having your database in a normalized fashion for being extremely efficient. And the reason I did it in CodeGrader is this, okay? A student logs in and is in CodeGrader. And it's very efficient for me to be able to associate with a student in a single lookup. I just want to read one thing, and I want to know all the classes that the student is in, right? This is very efficient. It's only one read. If I had a many-to-many relation, I would have to start to say, the student is the student. Let me do a lookup in the many-to-many relation to see which of the many classes. I would need to read many rows in the many-to-many relation every time the student tries to do something, because I need to check permissions every time the student does something in CoreGrader, right? Every access is separate from the others. So every time somebody lands there and tries to submit, I need to check, hey, can you really submit to this class? Yes, no. Yeah. Nobody likes to hear their own voice, isn't it curious? But if you follow me there, it's great, because so you can tell me if my Hangout crashes. Actually, I sound better there than in when I have the earphones and the Hangouts. Anyway, so efficiency is a very big consideration, okay? And I sometimes break the rules. So in CoreGrader, I broke the rules of DB organization. And so if you join an assignment, I need to do two things. I need to add the assignments to where you can submit, and I need to add you to the class list. And either these two have to both succeed or they have to both fail. I don't care very much if they fail, right? If they fail, you click there, you say, "Pah, this system is a bit crap." You click again, and maybe the second time you succeed. Provided you fail very rarely, it's not so incredibly important. I could, retry to do the transaction. So transactions can fail. When you commit, it might fail, okay? But the important thing for me is that either it's all done or it's none done. This is a very, very important property, because otherwise, if you rely on the consistency of the database, that things are in a certain relation internally, like, for example, that if a student can submit to an assignment, the student is also in the class list for that assignment. If you have these constraints in your database, which often you have, if your transaction would fail halfway through, okay, this would leave you in an inconsistent state. So it's incredibly good that transactions fail atomically. Either they all go through or they all fail. Now, how is concurrency handled in databases? There are 4 levels of what is called the transaction isolation, okay? Transaction isolation has this name because imagine that the database is serving many people at the same time. So many people are trying to do transactions. I'm trying to do read and write, you try to read and write, she tries to read and write, we're boom, all together, right? So how isolated are we from each other so that we don't modify or overwrite each other's data without in an inconsistent way, okay? So there are various levels, there are generally 4 levels of transaction consistency that you are giving, or isolation that you have available in MySQL and in PostgreSQL, and I think Oracle DB is similar. A repeatable read means this: if you read twice the same row, you will get the same value. So, for example, suppose I have a row that says class list. Okay, if I read it twice within the same transaction, I'm gonna get the same class list. This sounds trivial, but it's not, because, for example, I could read the class list. In the meantime, Joe could join it, and I can read it again after, half a second. But in the meantime, Joe has joined. Will I see Joe or not? No, I won't. If I see repeatable read, once you read a value the first time, the second time, you don't try to read it again. You read exactly what you read the first time. You essentially cache it, and if you try to read it again, you are given what you were already given, okay? This is called a repeatable read, not because you can repeat reads, because if you repeat them, you get the same thing, okay? And it's the default for MySQL, okay? It does not guarantee that you don't overwrite each other's data. It typically does not, okay? So you can still shoot yourself in the foot beautifully by letting 2 different people buy the same seat, for instance, okay? So, many times, it's okay to use a repeatable read. A repeatable read has the advantage of being very efficient to implement, so that's why people like it, okay? Compared to other isolation types, it does not come with a big overhead in terms of milliseconds for reading. Now, many times it's okay. For example, suppose I use, sorry if I use these examples, but it's easier for me to do examples on things I know than things I don't know, right? But for example, in CoreGrader, many transactions are done with a repeatable read. Why? Well, if I'm only reading, I might as well use a repeatable read. And most things just read. Sometimes I'm modifying stuff, but most often you are modifying stuff that is your own stuff. That means every user is modifying things that affect the user only. So suppose that I go in and I update a little bit my submission. Nobody cares. Yeah? There's nobody who can possibly overwrite my data because it's my submission and I'm the only one who can do it. Okay, so it's not so important to prevent me from overwriting myself. Okay, and so I use repeatable read because again it's very efficient. I pay a very low penalty in terms of access cost. Are these things clear, or is it above your head because and I should do it later because you haven't seen enough development examples? Maybe we should come back to it later. What do you think? Well, but you have seen that I can edit records in a database, okay? So keep it in mind because this is useful to know from the beginning. If you want later to do it, to me to come back to it, I will, okay? But I think it's good if you keep it in mind. Now there are some other transaction levels that I've not used widely, and I'm not a particular fan of it. Read committed means you just read the last thing that was committed. It means if I read the same thing twice, I might get different values. It's the default in PostgreSQL. And I don't like it just because, I'm sure that if I ever made a mistake and wrote some piece of code that contained a bug, if I read the same thing with different values, I'm sure that I would waste a day or two before I figured out what I did wrong. Because it's extremely rare and it's extremely difficult. You write an algorithm and say that works on a graph, and because you read the edges at different times, so sometimes you may need to read the same edge, but the second time you read it, you're going to read a different value. Mind-boggling to me. I would never be able to find my bugs. So it's the default for Postgres, but I don't know, and I don't know that I would be able to keep my sanity. Read uncommitted means read everything you can. Doesn't matter much. You just read the latest value. I've never used it, and I don't see why I would use it, since a repeatable read does not have a large penalty. Serializable is the officially good thing to do. So serializable means that if I do a transaction and if you do a transaction, we don't know which one of us will get to do it first. But the effect on the database is as if the two transactions were executed in some serializable order. This is an incredibly important concept in operating systems and concurrency, the concept of serializability. Things might happen at the same time, but the effect has to be as if one comes after the other or the other comes after the first. Okay? So, for example, let's see what happens if for buying seats. Let me where I am. Where am I? Oh, then what I can do is this. So if you want to buy seats, what could happen? Okay, there is a read of the same element. Okay, so there is a read and a write, and you come after me, you do a read and you do a write. Maybe you don't write anything because you cannot buy the seat. Okay, but I don't care in this case. But suppose we have to increment a counter. I read the value, write the incremented value. You read the value, write the incremented value. Beautiful. Okay. No problems. Now, suppose that you read, I read, I write, you read, you write. What would happen here? Okay, a database would check this. I read, you read. So there are various implementation possible. One is that when I read these, I put a lock on the row. When I write, I use my lock and write. But at that point, I've written it. So there are various things that you can do in a database. And I want to maybe at this point scheme, maybe I will come back to it in detail. Okay, but there are two things possible. Either the database will decide to arbitrarily delay your read. It will see, hey, this person is trying to read from a row the same row that somebody else has locked in a transaction. So if you try to read it, I'm actually waiting before I give you the result. Okay, so that in practice, in time, it's as if this is the way time passed. Read, write, read, write. Okay, the database is artificially delaying the reply to that. The other thing that can happen, and this depends on the details on how you do the read, and I may want to cover them next time or later on. But the other thing that can happen is this, that these two people really read in this way, then this writes. Then when this tries to write, the database will realize that it's trying to write a value that has already been written, and so that this write would overwrite, okay? So when these, you know, there is a commit at the end of each transaction, if you see. There is start a transaction and commit. When this person will, this write will not take effect, and when this commit will be done, all the effects of the transactions will be removed. So all the data that the transaction writes, if you use serializable, when you write, it's not actually written, the stuff, until you do a commit. When you do a commit, you either write it all and do all your modifications, or it's said that you roll it back. That is, all the effects that you might have done are undone, and all the logs that you may have acquired are removed. So if you did this, what would happen is that the second person trying to increment the counter would receive a message that the commit failed. Okay, and then you have to decide what to tell the user. For example, you know, in a seat reservation system, you can tell them, "I'm sorry, but I don't know. Actually, even these nice sites like Orbitz and Expedia don't tell me anything very nice. They tell me something like poof, and they send me back to the screen where I can choose seats." And so I realized that somebody cheated me on the seat or something like that, right? And I mean, that's what happens to me. And that's a good thing, because, you know, users are basically a little bit clueless when they use websites. We are used to stuff, you know, that mostly works, but not quite. And users are very naive. So I think that in practice, it's better to just, you know, you try to buy the seat and just show them the seats again. These people, you know, most of the people are, you know, busy. Maybe they're drinking coffee, taking notes. So their mind, you know, will reset of, okay, let me choose a seat, and then we just resume from where they were, you know, and it will be good. If you try to tell them, "I'm sorry, but it appears that somebody concurrently tried to reserve the same seat, and it appears my logic for resolving conflicts has favored the other person. Would you mind trying again?" If you told them something like that, your mind would blow. They would say, "What's that? I just want a seat. And where can I click to get my seat?" So, so in general, you know, it's okay if on the web, you know, people are resilient to this sort of mental baths in which, you know, poof, they're back where they were and things didn't really happen. It seems, you know, that we have sort of gotten used to sort of this, not sloppiness, but some sort of, you know, flakiness is the right technical word, I guess, of the web, you know, in which things might or might not happen. If you get a confirmation, they might have happened really, but otherwise likely not, no? And so it's perfectly okay if the transaction, in fact, I think it would be a bad idea in a web system to retry transactions too often. Because if something fails and you try it again, well, first of all, you don't have a guarantee that it succeeds the second time, right? And also you're introducing delay. And if you introduce delay, you know, the user may be on a cell phone and now, boom, the elevator's door closed. I mean, in the world, the things can fail for many reasons. Not only the reasons due to your system, no? The user may switch application running, get bored, the connection might fall, you know, the light may go out or whatever, right? And so it's pointless to do things that retry too often, and at some point you just let the user retry, okay? I don't think it will be a good idea to retry a transaction that you measure can fails only one case out of 1% of the time, okay? Now, this tells you also another thing, that suppose you want to do one of these sites, suppose you have a site and you want to count how many visitors you have, and suppose you have really a lot of them, okay? Suppose that you want to count how many visitors you have, a very reasonable thing. So you have a counter that you increment in this way, but the counter needs to be in a transaction if you want to increment it. Transactions are expensive. these isolated serializable transactions are very expensive in terms of processing time, because you need to use locks. So when you read, you must say, hey, this row has been locked for reading and possible modification. And when you modify, you say, now I really modified it. And so you have to manage all these locks and all this stuff, etc., etc. So databases, can manage only a certain number of simultaneous transactions of this type. Not very many, maybe 10, maybe 20, especially that involve the same data, okay? But many sites have more than 20 visitors per second. So you cannot count visitors in this way. Counting visitors in general, or implementing counters, is in general a very difficult problem. It sounds very silly, but it is. It's very difficult to design counters that are cheap to implement and that can scale to very large sizes, okay? A typical way to design counters for large sites is this. Every user has a user ID, and you compute a hash of the user ID between 0 and 1,000. You can take the user ID and divide it by 1,000 and get the remainder, if you like, okay? That will tell you, for example, I'm number 38. Okay, if I'm number 38, my visit will increment to the 38th counter. You keep 1,000 counters, and every visitor will increment only one of them. So that essentially every counter is incremented with at a rate of number of visitors per second divided by 1,000. Okay. Now the problem is that now you have 1,000 counters, but you need to compute their total. Then that's very expensive because you need to read them all. And you need to read them all while people are trying to increment them. So you still haven't solved the problem really, but at least it means that between these transactions of this type, you are just trying to read, which is not going to cause a conflict with the writes. And so that's a way in which you may implement counters. But in general, implementing counters, so the message is that it's difficult. It's expensive, especially. People don't realize it. They believe it's very simple. But in a database, it's very what is simple are the things that do not interfere with each other. Those can be done with repeatable read transactions, and those scale to larger volumes of transactions per second. But the things that cause conflict, counters or any other thing like that, those are the things that actually are going to be the bottlenecks of your performance. Okay? So let me restart the screen sharing. Okay, so this is about transaction isolation. Once you choose your level, if you want a non-default level, you say set the transaction isolation level serializable, and then between the start transaction and the commit, you can actually put whatever you want. But so this is something to keep in mind, and the difficulty of it is that it's hard to test for it. So you better get it right in your mind, because you won't discover this type of errors due to longer serialization if you are the only one on your development system who every now and then does a web access. Okay. So the other thing is this. SQL injection attacks. These are, one of the primary ways to get information out of websites. Some of the original Sony hacks of a couple of years ago were done in this way, etc. So what happens? SQL is a beautiful language, okay? And many of you, in fact, will be tempted to write directly in SQL inside the web, inside Web2Py. You just write an SQL query because you know the syntax already. So why is that not such a great idea? Because of something that is called SQL injection attacks. So oh, I'm not in presentation mode, so if I click, nothing happens. Okay. So suppose you want to add a student to the school database, and you write this. Connection exec is the way in Python in which you send a string to the database. When you connect to a database, you get a connection object, which is like a pipe in which you can stuff commands for the database to execute. Okay, So you say connection exec, and then you can pass the string that you want to be executed, okay? And then you will get some result. So suppose you say connection exec, insert into students email name, values, and then I want to insert the values that come from the form. No? This is a form processing piece of code. So the student, you have created a form with email and name as the two fields. And I'm saying the values are form.vars.email plus comma, quoted, plus forms.vars.name plus, the end of the string. Okay? So this generates a string that I can send to the database, and the database will insert the data. This sounds great, right? And a lot of people used to do this. Now, this is really bad, however. And the best way is explained in this very nice XKCD comic. No? So, well, we did. So the explanation is this, okay? This piece of code here does not quote the content of the email and the name of the student, okay? So when the name contains this Robert, quote, parenthesis, semicolon, drop table students, the database will think, aha, it sees a quote, right? And it will believe that that's the end of the string, okay? So it will not wait for this quote here. The quote that is in Robert quote will end that. And then there is a parenthesis and a semicolon, like here, and that will be perfectly the end of the statement. Okay? Oh, I think I have made a mistake here. I should have switched the use of semicolon quotes, single quotes, and double quotes. But essentially, this will close the statement. So the database will insert a student of name Robert. This will be executed outside of the name. This will not be taken to be part of the name. And the table students will be dropped from the database, so all the data will be gone. Okay? Now, people who do SQL injection attacks don't typically do this because, they don't want to delete data. They want to extract the data. But for example, they will, suppose I'm in a database and I'm called Luca, okay? Then I instead of this, and I want to steal your credit card number, then I do something like this. I insert some data, bogus data, and then, I prematurely close that query, and then I say, update Luca comment. I'm giving you the gist of, not the syntax of how I would do it, okay? But I update Luca comment field with the result of doing a select on George for his credit card data field. Okay, so the database will execute everything and will execute that. And then I go to look at my comment field. In fact, I will not do that. I will say, fetch one row at random, get to the credit card data field, and put the credit card data field inside my comments. No? So every time I go, I will find the new credit card data. Cool, great. No, and I can leak data out slowly. Okay. Or maybe I can, get the encrypted password of a few people and their usernames. Then offline, I crack them, and then I can get access to their account. That's another thing I can do. Okay. So essentially, these, there are two major ways to shoot yourself in the foot in computer science that have not been eliminated throughout the time. One way is quoting. No, when you pass strings to another system, the other system will want the strings to look in a certain way and not to contain certain characters. And so if you have strings that are more general, you need to quote them, right? So the correct way to send a name that contains a quote, and many names contain quotes, like De Francisco, I don't know, with a DE apostrophe F Francisco. There are all these names that contains quotes or strange characters. But so you take these quotes and you quote the quote. For example, you change it from Robert quote this. If this is a name string, you should pass to the database something that looks like Robert. Then you quote the quote, and then and then the parenthesis doesn't need to be quoted, and then you close the whole string. With this backslash is used to quote these, okay? But quoting is a mess, and the reason it's a mess is that, well, it's moderately difficult to do it once, but it's infinitely difficult to remember whether you have done it or not. You get some piece of data that comes from somewhere else. Is it quoted already for the database? Yes or no? Boo. If I just read it from the database, it's actually already quoted. If it comes from the user, it's not quoted. How do you figure out which is which? No? I mean, you usually can figure it out, but you cannot figure it out 100% of the time for all the data. So attackers just keep using your site, injecting these funny characters until they get you to break. When they break you, they get one of these server error responses. They figure out, aha, he's making some mistake. And then they inject the data there, that will cause the database to execute what they want. That's roughly how it is done, okay? So people have tried to invent type systems that say, instead the strings are not all strings. There are quoted strings and unquoted strings, and the type system tries to infer whether the string is quoted or not. Good. Not simple. So instead, the solution is this. If you access the database via Web2Py, Web2Py will take care of and not only Web2Py, but all these web frameworks, they will take care of talking to the database, and they do the quoting on the way to the database, and they do the unquoting on the way from the database. So one of the big reasons why I really want you to not to write a raw SQL, but to write in Web2Py is that in this way, your data access is safe. I mean, it's safe from SQL injection attacks. So the two ways of shooting yourself in the foot in computer science is one is quoting, and the other one is buffer overruns. Okay? And the auxiliary way for web is cross-site scripting attacks. That sounds very complicated, but they are the thing I told you last time. It's when you have a URL that has an effect that somebody can guess and can call even from not your application. Okay, so if I have this URL that deletes a piece of data, and the URL can be called from another tab of my browser, these would be a cross-site scripting attack. That's the name. I will go over them again later in more detail. But so these are the things I wanted to tell you about SQL databases, and we can do a little bit of examples. For example, where am I? Here. Okay. So a great thing I did is that I discovered to have my comments green. Let's try to build another site. Okay. Here I am. I create a new simple application. What would you like to have as an example? Well, let me think. Something that is not incredibly small or trivial to lay out the database for. For example, a restaurant with many dishes. No, that's too easy. A hardware store. But a hardware store, I mean, it's complicated if we go into details, but what's... an airline that tries to sell you tickets. Okay, fine. I mean, we don't do it the perfect way, okay? But we at least create some structure. Okay. So now I can go here, and I will have an example called airline. And I have tables.py. Great. Fine. So how do we do it? A typical thing is a flight. Okay, we want to remember a flight. So we have a DB table, and we call this table flight. I like to give names always in the singular, okay, so that the elements are then field. What do we need to know? Field from, fine, field to. Okay, I am assuming that this will be a part of 3-letter codes. Okay, and then okay, field flight number, okay, great. Now the problem is how do I say when the flight happens? Okay, because I cannot say this 7 a.m. flight. I mean, well, I could do that, I guess. I was wondering whether to associate some periodicity, so that, you know, flight 780 is always the one that leaves at this time and arrives at that time. So this is a sort of the general flight, and then you can build the particular flight instances of it. Okay, so let's call it flight plan. Okay, so this is the flight that usually goes from a city to the other. Okay, now you probably have a schedule for this flight, and a schedule is essentially a repeated list of things that are, you know, a day and a time. So this is the times in which you think that the flight will take place. So I say db table schedule, and I can say something like this: field day of week. I will have a validator. If I want, I can say like requires is equal to is in, you know, and I can give a list that I can say more to so, and, you know, you can imagine it. I don't want to fill it all, okay? So I am not putting the details here as the validators. I'm focusing basically on the content. So field time, which is a date time dot time, and I have to say from date time import date time. Kind of crazy, but that's what you need to do in Python. No, actually, I need that for later, but I think I simply need to say that the type is time. Okay. And then, you know, this is a many-to-one relation. So a flight plan may have several schedules, right? And so I have to say, essentially, flight plan ID, db flight plan. Okay. Okay, then I can say db table. So this will be my actual flight. Okay, and I can say field like flight plan ID db flight plan. So I can say, for example, that this particular flight here, you know, the one on which you can actually buy seats, is an instance of flight 780. Okay, because the flight plan with its associated multiple schedules is, you know, when the flight should take place. But this one, you create an object like this when you actually decide that the plane will actually fly, and so you want to start associating details with it. Okay, so this is an actual flight. So it has a flight plan ID. It has like a pilot who may be a reference in another database, which is db pilot. Okay, there may be a table somewhere Oh, and this table we are defining it later. So I think we write reference DB pilot. Okay, and I know there are multiple pilots in a normal plane, but in a commercial plane. Okay, but we don't care so much. Okay, and so here, we will have to fill in the details of that table. So there is a pilot, and then there is field. What do we need? So we want to represent the seats of this field, of this airplane. But we, no, okay, let me, so date, which is a date time. Okay, fine. So this is a particular instance of the flight, okay? And now you can buy seats on a flight, okay? And so I want a table that tells me something about seats. db.seat. This is my representation for now, db table. Yeah, seat. I'm not gonna try to execute this code, okay? Anyway, so I'm making it easy for myself. So what do you know about as an airplane seat? So it has a number, which is actually not a number. Seat number. Yeah, people call them numbers even though they contain numbers and letters. Fine, we don't care. Okay. Fields. Field. Okay. Now there is a class. Okay. Then there is a field like a boarding zone. Okay. So which order you get people in? Field like not only class but how to like pricing, and you may want to add some pricing categories, like not all the economy seats are the same. There are like if you pay more, you get put more in the front or window. I'm not quite sure. And then there is another thing that is like a description. Is in so this is just to make it clear. Is window center, something like this. Okay. And then there is a field sold, and this may be a boolean. Maybe a free is sort of better. Well, I'm not sure it's the same basically, but and default is equal to true. So when you create it, is free by default. When you this is just an example, okay? And then if the seat is sold, you would have to make a many-to-many relation with customers. Okay, so you see already in this database I'm making some compromises for efficiency. For example, I wouldn't need the boolean. Okay, let me continue the example to explain this point. Now I may have a DB table like a customer, okay, and I don't really care what is in here, okay. Field name. For all I care, I just give it only one field. Okay. Sorry. For all I care, I can just put one field. But what I care is that I want to be able to have a table that says DB table reservations. Reservation, okay, and here I can put the reservations, and now I can say, sorry, field. No, I wanted to split here. Field seat, and this is a reference to DB seat. Okay. Then I have to say field customer, and this is the reference to DB customer. Okay. And then there will be other information like field confirmed, whatever it means, which may be a boolean. Okay. And then you can have a host of other fields like, did you pay for it? How much did you pay? you know, your whatever. So here already I'm using a little bit of this is not a purely nice database schema. Why? Because I have introduced some constraints among information that is not local, okay? So the constraint I have done here is that I have this field free. This field free should actually be eliminated, okay? I should know if a field is free by looking it up in the reservation table. If the field does not appear in the reservation table, I know it's free. Hence, I should not have a Boolean that says whether the seat is free. Otherwise, now I have two things that should be kept in sync. Because if I ever, you know, get them out of sync, for instance, and have no reservation, no row in the reservation table for that seat, but the seat is not labeled free, I will never be able to sell that seat, likely. Okay? And conversely, if I sell a reservation to someone but still label it free, I'll likely sell the same reservation to somebody else as well, unless I pay attention, okay? So here I have essentially created one of these constraints. But why do I create it? Because I'm imagining that when you build a website for seat reservations on flights, one of the very common things that you need to do fast is giving me a map of the available seats, right? So I want to be able to very quickly write a query that tells me, give me the free seats on this flight. And if I do this, I'll write the query here, even though, you know, it does not belong in this file. Maybe I write it with a comment in front, okay? But the query will be something like this, db, and so let me say what free seats in oh, okay, I forgot a field here. I mean, I forgot the reference to the flight. I want to know the free seats in flight FID, okay? So I do this query in web2py, db, and then I have to say db.seat.flight is equal to feed. And this is how you can do the conjunction of queries, of two clauses in the query, okay? And db seat free is equal to true, okay? Then I can say select. Okay, this will give me all the free seats on that flight. Okay, this is very easy. But otherwise, it wouldn't be quite as efficient to write this query if I didn't have the free field. What I would have to do is essentially a much more complicated query that would look like something like this: db seat flight is equal to feed, and now I don't want to have a customer. You know this, I don't know in web2py how to write this efficiently even. I would have to look it up. It's not an obvious thing to write because I need to count. Let me go logically overview of what I need to write, even though I would need to read the manual to be able to write this. I would need essentially to be able to say, I want all so the first clause I would keep it, right? I want all the seats that are in the flight that have flight is equal to FID. But then I would need essentially to count how many entries in the reservation refer to that seat and check that that number is equal to 0. You see, that's a much more complicated query. I cannot answer it using one table only. I need to access two tables and to check it to only give you the data from one table if there is no data associated with it in the other table. Okay? So this advice that I'm giving to you is essentially counter to official database theory. But when I design websites, I actually make sure, so people love joins. People love in database theory to be able to put together the data from multiple tables. I rarely do that. I try to answer design my tables so that I can answer as many queries as possible, especially all the performance critical queries from one table only if I ever can. Okay, and then I'm gonna absorb the headache of actually making sure that, you know, if I create a reservation, I check not only that the field is free, but that there is no reservation for that seat. And so I take the pain of doing more checks when I actually change the data, but I try to answer all the queries if I can from one table only. Okay, I do this because of efficiency. You know, you have much more often to retrieve information than to change it. This is one factor. You know, you can read hundreds of times more often than you actually write. Like, imagine an airplane reservation seat, right? So you have one row for each seat, right? When you click on the airplane, you need to read 250 of those elements, right? If you decide to buy, you modify one. So there, the ratio is surely bigger than 1 in 100 for writes against reads on this seat thingies. Okay, so it's way better that you optimize the case that is going to be way the most common. Okay, and the other very important consideration is that the user is impatient when reading. Ideally, you want all the pages in your site to load on under a second, even under half a second if you could get it. Okay. But you have to make sure that your site loads very fast. It has a big effect on the user experience. Okay. Instead, if I buy a seat, at that point I'm already committed. You know, I will also have to, you know, pull out my wallet, get the credit card, enter the data. I mean, it will take me 2 minutes, 1 minute. I don't know how long. You know. So if at that point the database access has not only to check the free field, but also that there is no reservation, and even if it takes, you know, 200 milliseconds more to do the, I don't know, whatever extra checks, nobody cares at that point. Okay, the user is already committed. So I essentially use in my work a semi-denormalized way of using the database, in which I really make sure that the most common queries can be answered very fast with the least possible number of accesses, possibly to only one table if I can. And I actually tried to avoid joins. The joins are the things like, you know, give me all, how would you write a join that makes sense in this case? But a join that makes sense is tell me all the flight list of this flight, okay? And so the query would be something like this, db, sorry, I need to think, okay? But okay, let me do it this way so I have the help. db, and then I need to say db seat dot flight is equal to FID. So this fixes my flight, okay? Then I need to say, aha, this is a seat. Now I need to find a customer that has a reservation for that seat. And db reservation dot seat is equal to db seat ID. So this fixes the fact that I'm looking at the reservation that is related to it. Okay, then now I say and db what db reservation dot customer is equal to db.customer.id. Okay, so at this point I have strung together all these three tables in a related way, and if I say select, Web2Py will give me the result of what's called a join. So essentially it will give me big rows. Every element of one of these rows will contain a row, a seat row, a customer row, and a reservation row in such a way that they are related in the proper way. Okay, so I get all the fields out in a single row. Okay, and so for example, I can do this. Let me write this piece of code. Okay, so I can say rows is equal to this. Okay, and then I can say for r in rows, and I can say I don't want to quite use a print, because a print doesn't exist, but I can say okay, and then in the view I can say something like this. Okay, for R in rows, and I can put out an element, HTML element that says like this, says something like this, like user, and then I can say R dot customer name is going to take flight, and then I have to say what db. Oh, because here I don't even have a flight. I have only a seat. It's going to sit in seat. This is what is it? Seat row dot seat dot number. Okay, something like this. Okay, if I wanted to know the flight number, I would have to add even another clause. To know even the flight number, I would need to repeat this code in this way. Okay, because you see, the seat contains a pointer to a flight. Okay, and the flight contains a pointer to the flight number. Okay, so I could write a bigger query in which I continue, and I say and okay, and I can say db seat flight db what is it? db flight ID is equal to flight ID, and you know, and I can go on fish out information in this related way. For example, and I can say db how did I call it? Flight plan ID is equal to db flight plan. I think I called it. Did I call it that way? Flight plan ID I called it. So I can go on writing things like this. I can traverse the database like this all the time I want. And then I can get these very big results. And I can say, insert this of flight. And then I can say row dot flight plan dot, how did I call it? In this flight plan, for flight number is called, okay? Flight number on day, and you know, I could fish out the data and do whatever I want. Okay, so for some queries you can traverse all the rows, but there is a very big difference. Okay, if I do this, I could actually write a query like this if I needed, without any compulsion. The point is that yes, it's a very complicated query. Yes, you are traversing many tables, but you are reading one row only, right? So it's not a very large cost. But if you need to read many rows, I would really try to be able to answer the queries from a single table. It's really a matter of efficiency. So you have to keep in mind when you design your database, essentially, what are the typical queries? What is the typical information that you need to know? And how easy it is to pull it out? Okay, and you really have to do a compromise between organizing the information in a logical way and having it fast. For example, if the typical query, suppose you know that you need to answer within 50 milliseconds of the query, is this a passport ID of a person on this flight? Okay, then I don't think this database organization is good enough. I would put this information in a special place, because otherwise you need to go, you know, from the flight to the seat to the reservation to the customer. Too many tables. You cannot do it in 50 milliseconds. And you may wonder, why do you want to do it in 50 milliseconds? Well, the reason is this. I have, you know, here, you know, I could have a driver license or a passport card or whatever, and I want to do ping and then walk to the gate, right? And if the ping doesn't happen in 50 milliseconds, but 1 second later, like, ping, okay, thank you, I mean, it needs to go fast. And if you want it to go fast, you can, but it has to be really fast. I mean, thinking that checkout of a supermarket, you go like, ping, and the price appears, like, ping, price appears. It's very different, and you have to think of these things, okay? So, okay, so this is a same introduction to databases. Now, these are relational databases. What do they do that is great, and what do they do that is not so great? What they do that is great is that they enable you to write these very rich queries. We saw a few examples there, but the query language is really quite varied. You can very easily count how many rows there are in an answer set. You can, as I indicated here, you can relate information in separate rows. So the query language is very nice and very sophisticated. To some extent, it's flexible. So aside from efficiency, even if you don't forecast from the beginning of the queries you need to run, you are always able to run one more query. Okay. And the other big advantage they have, the other fantastic advantage they have, is that they have transactions. The drawback is that they are expensive to scale. It's difficult to give you actual performance data because it depends on the databases, okay? But I mean, on the hardware you run them onto, etc. But if you, a typical database may be able to support some 100 or so concurrent transactions with, 100 or 200 concurrent connections. This means 100 or 200 concurrent thingies that are talking to it at the same time. And a typical database may be able to support something between 10 or 20 or so concurrent transactions. So this depends on how big the transactions are. But these are not particularly big numbers, okay? The problem is that these databases, because of the transactions, they need to be a single machine, okay? So, a small database is cheap. You just get, a PC and you host a database on it. But if you want to go 10 times faster, what do? Well, then you get a high-end PC with a flash memory and lots of RAM, so that, the database is stored in flash, and most of information of the database is mirrored in RAM, and then you can go really fast. And so, fine. And so if you look at these hosting plans from Amazon or from Google, you can find, that the price of the database depends essentially on how much memory you have. And so you start buying just 32 gig of RAM, and then 64 gig of RAM, and then, maybe 128 gig of RAM, and then maybe, this flash memory, and, pretty soon this thing is going to cost you $1,000 a month, or maybe more. I mean, there are the plans. You can look them up. For example, let's look at one of them up, like Google Cloud SQL pricing, okay? This, I'm familiar with it, so I can find the pricing information quickly. Okay, so this is a charge per day. If you want 16 gigabytes of RAM, you pay $35 a day. Okay, fine. And then you have to pay for the storage, which is okay, but not incredibly cheap, the storage, right? So let's look at the storage. Where is it? Hey, included storage. Storage size, you can go up to 500 gigabytes. It's really small. I mean, it's not small for a database, but it's, like Wikipedia data is maybe 10 or 20 terabytes. How are you gonna store it in there? You can't, right? And there are lots of things you can store in a database of these sizes. Amazon can go to larger sizes, okay? But the other problem is time. For example, at some point I had all the metadata of the Wikipedia database, over 1 billion rows. And I wanted to insert that data in my database. I didn't have it in the database. I had it, in some other format that I had produced. And, first I tried with a student to do it a stupid way. That is, you insert 1 billion times. And this would have taken a month. And then we had to go over all the possible tricks of inserting 1 billion rows in the database, even though the database in the end was only like half a terabyte, or a little bit smaller than that. So, these databases need to reside on a single machine, and they can get expensive, and they're anyway limited in size. So what do you do if you need to grow? What you do if you need to grow is that you use, in addition to these databases, some of the so-called NoSQL databases. There are several of them. There is MongoDB, or the Google Data Store is another one, and they are all different. Okay, they have different capabilities. So I can describe the Google Data Store if there is interest later, but let me at least tell you what it does. Okay, the Google Data Store. Let me be able to write. Yeah. Some people, I hope nobody from Google will be listening, because it will be a very simplified version of what it does. But essentially works in this way. You can create multiple tables, okay? But the tables are each table to itself, okay? You cannot join easily data from one table to the other, okay? So fine, you have tables, but they are independent. And each table has a key and then has a value. The value can either be a single value, or if you want it, you can split it in fields. Okay, for example, you can still have a name, and then you can have, I don't know, a phone, and then you can have an email if you like, and you can have a comment. Okay, so you can have things like this. And in fact, it supports various types of data. It supports strings, it supports floats, it supports dates, and it also supports interesting things like a string list, in which every element of the list of the string is indexed. For example, I can have, for example, tags. Okay, I can have a person can have multiple tags. Okay, and I can search who are all the people that are tagged as I don't know, like whatever the tag might be. Okay. So and this works, so it works fairly well. So what is the idea of why is the data store very scalable? Because when you have data like this, Google does not store it on a single machine, and MongoDB also uses the same principle. By the way, you don't put the data on the same machine; you distribute it across machines. So if you create a table that even only has 1 million rows, even though 1 million rows might fit on a single machine, they will be actually spread probably across thousands, hundreds or thousands of machines. Because Google will mix your tables with the ones of everybody else, I believe. Or it would be good if they did. They probably do. Okay? What's the advantage? Suppose you have to read your table very quickly. If all your data is on a single PC, then you're limited by the speed of that PC to get the data out of it, right? You cannot get it faster than you can get it out of a single PC. Imagine that you have like building Twitter, and everybody's trying to read their tweets, etc., etc. It's even if I could store all the tweets on a single PC, I wouldn't want to, because then that PC is going to be the bottleneck. I can only retrieve data as fast as that poor PC can give them out. It's horrible, right? If I spread the data out across a large number of machines, and when you give me the key of the data you want, I can tell, oh, it's on machine 37, then the accesses will be spread around across many machines, and you will be able to be much more efficient. Okay, so that's the idea. These NoSQL databases like Google Data Store and MongoDB have tremendous bandwidth for reading and writing data out of it, because they're spread across very many machines. Okay, very, very beautiful. The cost of the Google Data Store and MongoDB as well, but Google Data Store, I like it because it comes as a service. They maintain it up for you and you just connect to it. The cost of this Google Data Store is linear in the amount of storage and operations you use. It's not like an SQL database that is dirt cheap at the beginning and then gets more expensive and more expensive, because not only you have more data, but you have to buy more expensive hardware to possibly manage the data fast enough. No, you simply buy more of the same hardware. All these racked PCs look the same, and you just use more of them for your data. So you scale linearly in pricing and in bandwidth, which is exceptional. Okay. So this sounds incredibly good. So where is the catch? Well, there are two catches. One is that every table is per se. You cannot write queries across multiple tables. You can say give me all the users that have that have name Luca and the tag whatever and tag I don't know, professor. Okay, you can say queries like that. But you cannot say, but first of all, there are many queries you cannot do. For example, in the Google Data Store, suppose that you have some other fields here. In the case of people, it's a bit funny, but let me write, for example, suppose that there is age and weight. These things are distributed across tables on many machines. So they cannot have indices that work in a complicated way. If this was MySQL, you could say, build an index, first on age and then on weight. So I can answer easily the question, tell me everybody who is 49. Me, okay, and others. Fine. Okay, and then you can say, tell me everybody who is 49 and weighs more than so many pounds, kilos. Okay, fine, you would be able to do that as well. Okay, because there are indices that are keyed by the first and then the second component of the index. Now, assume that you want to do another query. Assume that you are in the Google Data Store, okay, and you want to find who are the overweight babies, okay? You will want to ask who has fewer than 3 years and weighs more than 100 pounds, okay? I don't know if there's it's just an example, okay? I have no idea what they would be looking for. But in the Google Data Store, you cannot do this. You can essentially have only one inequality in a query. I mean, you have only one field at which inequalities apply. You can ask who is between 50 and 60 in age, or who is between 100 and 200 in weight. That you can do, but you cannot say everybody of this age that weighs at least that much. Okay. As another example, imagine that you are storing photos in a Flickr-like service or in an Instagram-like service. But so imagine that a photo has there is a photo ID, then there is a date in which the thing was uploaded, and then there was a rating. Okay, the rating, you're tempted to keep it as a floating point number, and then you would like to say, hey, give me everything that has a date after yesterday that has a rating of at least 4. So you get the greatest photos of the last day. You can't do that in Google Data Store, okay? Because that is two inequalities on two different feeds, okay? And so the way to do it is that the rating, you maybe have it like as 1 star, 2 stars, 3 stars, no? And you can say, give me everything that is more recent than yesterday and where rating is equal to SSS. And that will give you the result, because there is only inequality on one field. So long speech to say, you lose in flexibility of queries if you go to the Google Data Store. You lose on the fact that you cannot relate tables, and you also lose another incredible thing for web design, that is transactions. So the way the Google Data Store works is this. Suppose I invent a key for people, okay, or for photos. Let's take this photo example, which is somewhat more appealing for this. So every photo will have a photo ID, okay. Now, if I tell you, if I now insert photo with ID 37, okay, so insert a table, insert a row with a key 37 and this content. Boom, it inserts it very fast. Then I say, hey, please read me the row with key 37. Boom, it will read it back to me. Great, beautiful, fantastic. Now, assume that I do the following. I insert a photo, a new photo, and I don't specify the key. There is a way in which the data store will invent a new key for you and give it back to you, okay? So assume that I add a new photo that I know that is taken today and has 3 stars. So boom, I inserted a photo. And what do? In your web application, you will likely write something like this. Okay, you will likely write a page that is called insert. In which you insert your photograph and you say, please go in. Okay, And then you go to another page that is the index that will, contain the list of all the photos that satisfy some criteria. For example, it will give you the latest photos, okay? So what will happen, okay? You insert your photo, this photo gets inserted, the row gets created, you get the photo ID, and then you go to an index in which you search all the most recent photos. Well, your photo will typically not be in it. Why? Because the way the things are inserted in the data store is this. First, a row is created very quickly. Then, asynchronously, the indices are updated. So by the time you go there, typically the index on the date is not yet updated with the new data you have inserted. It may take, from half a second to even sometimes 10 seconds in bad cases. Between the indices reflect the most current data. There is a delay in indexing of propagation, which means that it's actually not trivial to use the Google data store directly for your web applications. Because you typically insert data and then you want to be able to find it via queries, right? And here you insert the data, you can find it by key immediately, but you cannot find it by query immediately. So unless you somehow remember on the side that you inserted it, you cannot get to it. Is this clear what I'm saying, or is it a bit beyond your point of interest right now because you haven't started writing a lot of web code yet? I want to finish telling you this just because I saw you now at the beginning, and I can come back to it towards the end of class when we have more time to talk about efficiency and this type of things, okay? So the other consideration, so essentially, using the Google Data Store is not trivial for web applications because of this point that queries have a delay and users want to reply immediately. And so you need to essentially remember on the side what the user just told you so that you can supplement what comes from the data store with what the user just told you. It's a big headache, a very big headache. So what are the solutions? There are various solutions. One is, one solution is, you just use MySQL. You pay more. When you will be at the point in which it really becomes very expensive, maybe you have more developers working with you, and then you can transition to some other arrangement. This is one possible solution. The solution I use often is the following. Actually, CloudGrader is built along this solution. Because of my experience with the Wikipedia database, I don't like to put a lot of data in a database. The smaller I keep it, the happier I am. But I really like the transactions and the immediate availability for queries that come with a database, right? So what I do is this in CloudGrader, for instance. I keep all the data in a database, except for anything that can ever possibly be large. So for example, when you write a review of another homework, okay, I don't put the review in a database because it's wasted, the database for that. The review is just a big piece of text. So what do? I have a table in the data store that is called key value, and it has essentially, a key, and it has a value, and the value is just a big string. So when you write a review, I do the following. I take your review and I put it in the data store. The data store gives me a new key. Great, the new key is a very short string. It's like a 10-digit integer, essentially, okay? I take this 10-digit integer and I put that in the database. My database will always stay small, and I have all the extra data in the data store. Some things become a little bit more complicated because, now when I back up, I don't only have a database to back up, but I also have the data store to back up. No? So, I mean, it does add some complication. But essentially, I have, CloudGrader has, processed, I think, I haven't kept track, but I think we're well over 100,000 reviews and things like that. And the database is very small in size because all the text and all the data of that kind sits in a key value store that sits in the that uses the Google data store. Now this change is quite easy to do. Okay, so one thing that you could do is this: you could start with a MySQL database in which originally the actual review is in a field of the database. And then when you say, yeah, okay, this is no more a toy, and now I want to do this for real, and I want to be able to scale, it's actually not very hard it's not actually very hard to implement a schema like this, because let me just, okay, maybe I should give you this piece of code another time. Not this time, but when we do a bit more on the database definitions. I want to show you how you can possibly do that. Yeah, I think it's a useful piece of code, so I'll pass it to you how to use. I don't know. Maybe I can try to say it now. Let me think. Let me think a moment. Okay, I may come back to it another time, but the basic idea is this. Suppose you have a field like that a reservation has a field comments, okay, and this can be potentially large, and you don't want to keep a large field here, okay? So what can you do? The fact is that Web2Py enables you to define a representation for a field. So the field has a content in the database, but how do you represent it? Well, I can do this. I define a function like that is called getComments, and gets as argument a key. Okay, and the function will simply say NDB. Okay, I don't want to write the actual code because I don't remember the NDB API by heart, but it's something like value is equal to ndb.get of key. Okay, no, it's not this, but I have to say something like a key is equal to ndb.key of key. Value is equal to key.get. So this will read from the data store. What I'm writing is likely not correct, but it's approximately correct. So if you read the actual documentation, it will look similar, okay? And then I say return v. Okay? So this will read a comment with a particular key from the Google data store. And here I would have like to say which table to read it from. So this is, I read it from my key value table, okay? I think this is slightly more correct. But then I write something like this. I say db.comments, no, db.reservation.comments.represent. Okay, I can define representation functions that tell me how the data should be displayed. And these functions take the row and the value and need to return the display for the value. So this would do it. This would automatically replace the key in the database with a comment taken from the Google data store. Okay, so what this does is this. I'm telling that in order to represent a value v of a row r for the comments, the row I don't care about. But essentially, I take the value in the database, and the value of the database will be the key to the data store. Okay, I pass it to this function that gets the comments. This will return to me the actual comments that I will use in place of the value to display what's in the database. That's basically what I do in CodeGrader. Doing the update is a little bit more complicated because I need to remember, if you give me this in the form, first I read it. First, I write it to the data store, and then I get the key, and I make sure that in the database you put the key rather than the original comment. It's not very hard. But this is what I'm doing. Okay, so in practice, now we can go over these details as much as you like in the future classes. Okay, and if you will be, you know, the last part of the class we will have time to spare to go over all these complicated things. But this gives you an idea of how to put your data in your databases. So essentially, try to keep in mind the most common ways in which you will need to look it up, and make sure that those ways can be fast when necessary. So make sure essentially that you can answer the common queries as fast as you can. Okay. Initially, it might be okay to leave everything in a database. I certainly advise you for the class project, unless you are particularly ambitious. But think that in the long run, a very good organization is to leave for the database the metadata that needs to be consistent, searchable, and possibly small. And you put everything that is ever large somewhere else, like in a key value store, like the Google data store, that is dirt cheap in quantity and you know, can scale without any trouble. Okay, so these are essentially the design issues for how to lay your data around. I can tell you that in fact deciding the data layout is one of the things that in the end consumes most of people's minds and times. And now I've told you about the database and the Google data store. And MongoDB is very similar to Google data store at some level. You know, I mean, they're different in the details, but you know, they basically also store large key value collections spread across many machines that have high bandwidth. Okay. But there are other ways in which you can store your data as well. There will be mem caches, there will be blob stores for large pieces of content, etc. We will do talk about the others later, okay? But essentially, I find that a lot of the time that occupies a designer's mind is, you know, where do I store data, how, so that it will be cheap, faster to access, and will scale without giving me headaches next year. No, I mean, this set of considerations are what drives most of the design. So, comments? Yeah.
I don't really understand why the data store is better than the database.
Yeah. Why is it better? It's better essentially because if you have a very big table, what the data store does is something like this. Okay. Because the data store doesn't care about you doing related things on many different tables, it takes a very single big table, you know, in which you can have, you know, 5 billion rows or whatever, okay? And then it chops it up and it puts it, okay? It puts each piece of the table, each one of these 4 sections, say, but there are many more in reality, it puts it on a different machine, okay? So if you wanted to have a bigger table, you don't need a more powerful machine. More powerful machines are really expensive because, you know, we know only a few ways to make them more powerful, and they're all very expensive. It's like, you know, a Ferrari is not so much more powerful than a Honda Civic. I mean, look at the ratio of price and the ratio of horsepower. A horsepower Civic is 120. A Ferrari is what, 500? I mean, it's 5, ratio of 5, 6. It's crazy, no? And for computers, it's a little bit the same. So it's much easier to buy more of the cheap ones than to try to have a high-performance one that can do everything fast enough to keep everything running. So basically, the advantage of the data store is that you put these tables on different machines. The access is not so fast. So a typical access from MySQL kept locally and done well is a few milliseconds, 2, 3, 4 milliseconds, maybe 10 milliseconds. But if you can manage to keep a lot of the data cached in memory, the average access is very fast. The average access to data store is more around 30 to 40 milliseconds. Because there's a round trip time, these machines, because there are many, they cannot all be next to you. They, you know, will be somewhere in the same data center. But you have to wiggle your way through the network until you get to them. So I observe times around 30 to 40 milliseconds typically, okay? But it's much cheaper and it's more scalable. You say, I want it bigger, fine, you know, there will be more machines to use. And when you have used enough machines, you know, Google will buy another data center, will fill it up with machines that are again all the same and they will get used. It's much simpler. That's the main advantage. And the advantage is because these tables sit on different machines. If you have like if you have like Facebook and you have a billion users at the same time, these users will not be trying to read all from the same database that is on the same machine. It would be totally unworkable for something like Facebook, right? This information will be spread around many machines. Every user will be talking to different machines because the information will not be on the same one, right? And so the load and the access load will automatically get distributed across all these machines. So these are the advantages. So you essentially give up on features to gain on scalability. That's a quick summary. Other questions? Okay.
Are you expecting us to buy a scale server?
No, if you use Python anywhere, I think you get some kind of hosting for your MySQL. But if you did, it would be quite simple, right? For example, if we go back to the information here on the pricing for Google, you can buy the pricing of a small instance is 2.5 cents per hour. So if you keep a Google SQL server always on of the smallest instance is about $18 a month. But you wouldn't be keeping it always on. Even if you wanted to host your class project on Google's cloud, right? And similarly for Amazon Cloud. If you don't keep the database always on, you will likely be spending $5 a month. And I wouldn't find that expense excessive, frankly. This is a class in which there is no textbook cost. So if you spend $5 in hosting, fine. Yeah. But I would not advise to set up your own MySQL, except for development.
Otherwise, I'm going to buy one year.
Okay, great. Yeah. And again, Python Anywhere is one of the cheapest ways to host your project for this class, I think. Not because it's only cheapest, but because it's easier. So, I recommend you look into that. When you do the project proposal, talk to me, write a section about how many users you hope to be able to use and where do you plan to host your project. And I think we will give you suggestions and comments. And another very good place where to discuss these things is Piazza, because, I'm doing some things and I know where my things are hosted. But I do not always search for alternatives because, since they are hosted there, I cannot move them all that easily after I host them. So sometimes it's you or me that is most up to date with the particular offers or discounts that are available for hosting on whatever place. I plan later in the class to talk a little bit more about hosting and services, okay? This was meant just as an introduction to lay the data out, but okay. Questions or prepare the questions for next time so you slow me down and the class is more entertaining.